Hello everyone. In this video, I'll be discussing dimension reduction and demonstrating how to identify multicollinearity and apply principal component analysis using Python. So let's begin with definition of multicollinearity. So multicollinearity occurs when two or more independent variables in a regression model are highly correlated. This means they carry similar information which can make it difficult to understand the individual effect of each predictor. High multicollinearity can lead to the following issues. First is unstable coefficients. Small changes in the data can lead in large swings in coefficients. Second issue we have is misinterpretation. In this, it's harder to know the true impact of each predictor on the dependent variable. And third issue we have is reduced model reliability. The higher chances of overfitting reduces the reliability of this model. Then there are several problems that are caused by multicollinearity. First is unreliable coefficient estimates. In this, the coefficients of the independent variables become unstable and sensitive to small changes in the data. Second is this makes it difficult to interpret the individual impact of each variable on the dependent variable. And second problem we have is inflated standard errors. In this, the standard errors of the coefficients increase, making it harder to reject the null hypothesis in the hypothesis testing. Then we have second reason as a result, the model becomes less reliable and less precise. And third main problem we have is difficulty in identifying the true relationship. In this, it becomes challenging to determine the true relationship between the independent and dependent variable. Then we have the model may incorrectly assign the impact of one variable to another. So these were all the problems which are caused by multicollinearity. Then we have code related to multicollinearity and its output. Its output is in the form of matrix, 3 by 3 matrix, and these are the variables. And here is the explanation of the previous code, in which first we import some libraries such as Panda for data manipulation and Stats model for statistical analysis. Here are the libraries. And then we create sample data and create a sample data frame with independent variables x1, x2, x3 and a dependent variable y. Here are the independent variables x1, x2, x3 and a dependent variable y. Then third is correlation matrix. Calculate the correlation matrix using the core method. High correlation coefficient indicates potential multicollinearity. Here is the core function that we talked about. And then fourth step is VIF calculation. VIF calculation for each independent variable using the variance inflation factor function. And here is the variance inflation function that I mentioned. And fifth we have is a VIF greater than 10 suggests higher multicollinearity. If we have VIF greater than 10, that there is a issue of high multicollinearity. Here we have printed VIF. So this was code regarding multicollinearity. And next topic we have is how to apply principal component analysis using Python. So let's start with introduction of principal component analysis. So principal component analysis is a powerful statistical technique used for dimensionality reduction. It is a way to transform a large set of variables into a smaller one that contains most of the information in the large set. Then why should we use PCA? First is dimensionality reduction. In this, it reduces the number of variables, making data analysis and visualization more efficient. Second is noise reduction. In this, we can help remove noise and irrelevant information from the data. And third, we have is feature extraction. In extraction, we create new features that are linear combination of the original ones or the original features. Then we have visualization. In this, it can be used to visualize higher dimensional data in lower dimensions. So, as it was mentioned before, PCA is a multi-step process. So here's an overview of PCA. First, we have a standardize the data. So PCA is a sensitive to scaling. So we can standardize features to have a mean of 0 and a standard deviation of 1. Then second step we have is compute the covariance matrix. In this, the matrix shows the variance and the relationship between different features. Third step we have is calculate eigenvalues and eigenvectors. In this, eigenvalues indicates the magnitude of variance which are captured by each component, while eigenvectors show the direction of these components. Then fourth step we have is select principal components. In this, we choose the top k component that captures the most variance. The number of components is a trade-off between dimensionality and information retained. Then final step we have is transform the data or the transformation of the data. In this, we project the data onto the selected components, reducing the number of features. So here is the code related to the PCA. Mm, phew. So next we have is the explanation of the previous code in which we import libraries for data manipulation such as Panda, which is used for data manipulation, NumPy, which is used for numerical operation, and then we second step is preparation for data. In this, we create a sample data frame with three features. Here it is, sample data with three features, x1, x2, x3. Then we standardize data. Standardize the data to ensure that all features have a mean of 0 and a standard deviation of 1. This is a crucial for PCA as it assumes the features are normally distributed or equally. Fourth, we have is create PCA model. Here we are, it is the code for creating PCA model in which we instantiate a PCA model with two components, which means we are reducing the dimensionality to 2. Then we have fit the model. Fit the model means fitting the PCA model to the standardized data. Here is the we are fitting the data to a standardized form. Then we have transform data, which means that transforming the data to new principal component space. The seventh we have is creating data frame. Creating a data frame means a new data frame with the principal components as columns. Here it is, we are making them in the form of columns. And final eighth step we have is visualize the data or visualizing, which states to visualize the data in 2D using a scatter plot. So here output is in the form of scatter plot. So this was all regarding PCA model. I hope you liked the video. Thank you.